Good morning, boys and girls. How are you today? Today's the big teacher parade, so I hope I'm going to see lots of you out there. Right now, I just want to introduce you to two more members of my family because they'll probably be running in front of the video. So Otis, come here, come here. This is Bailey. This is my son's dog, and this is Otis. Do you want to turn around and say hello? Turn around and say hello to the camera. Okay, they can't because they know that I have food. All right. Okay, guys. So now I'm going to throw the food over here, and maybe you'll stay out of the camera, but I doubt it. Okay, so today I just want to talk about a few things. Okay, hi, Bailey. Hi, Bailey girl. Hi. I first want to talk about taking the survey. Please, boys and girls, take the survey. We have 57 fifth graders and about 35, maybe 39 have taken the survey so far. So if you talk to your friends, just ask them if they've taken it and remind them to take it if they haven't. It was sent to their parents' email, and it takes about a minute. It's just two very quick questions. So if you could do that, that would be great, and then we could start our line plot. Next, I want to talk about the patterns. Several of you sent patterns in that you saw on the calendar, and I really love them. I'm sure others still have them at home. I didn't need to see them, but we are going to discuss some of the ones that we did see. So if you have a minute, you might want to, after this video, take out the patterns that you noticed and see if you noticed any of the ones that we have down here already. We're going to do a quick review of the calendar grid. And then you're going to take it from there. You're going to do the other days. And I'm going to be sending you a new Mathological Liar that was written by our very own Addison McClosowitz. She created a case on her own, and I think you're going to have fun solving it. Tomorrow, we're going to be reviewing volume. So if you have a moment, you can look through your journal and see if you can remember what we learned about volume, maybe some of the vocabulary words we use, some of the labels we use for volume, and some of the formulas. So that's just giving you a little preview of what's to come. Okay, let's get started. So the first thing that we're going to go over are the patterns that you noticed in the March calendar grid. And if you remember, I sent you pictures of each of the calendar days by the 5 days of the week. And this is what some of your friends noticed. Liam said he noticed that the colors went from 5 with pink to 5 with yellow. And if we look over here, yep, the first 5 days all have some pink on them, and the 5th day is all pink, and then 6 through 10 all has yellow on them. And we also did number 11, and you'll notice that it's a blue rectangle, so I'm guessing that you would know what the 15th day might look like. Okay, Nick noticed that every multiple of 4 is blown up. So I love that Nick used the word multiple, and I know where it's coming from. But if we look, it's every 4 days of the pattern. And because it's 4 days of the pattern, and the pattern is 5 days, it's not a multiple. Day 9 is not a multiple of 4, but he was correct in saying that every 4 days in the pattern is blown up, because the actual rectangle is so small we wouldn't be able to see it unless they enlarged it. So that was good noticing, Nick. He also noticed that every 5th card doesn't have a model with it. So here we have all the models written on the grids, and then on the 5th day, it doesn't have a model. And they aren't looking for area, they just have the expression. And again, every 5th day, it doesn't have a model. Great noticing, Nick. Harrison said that all the digits are the same for the 5 days except for the decimal points. The decimal points are in different places, so they make the expressions different, but all the digits remain the same. And I'll take it a little bit further and say all the digits remain the same in both of the factors and in the products. Aiden said that the pattern, and this is a really interesting one, he didn't use this, or maybe he did. I think instead he used his chart to look at the differences for each of the days. And he said when he looked at the pattern, he saw that it was a whole number expression and then one decimal place value less than the whole number expression, one decimal place value less than the whole number expression, and then it skips to 3 place values less than the whole number expression, and it ends with 4 place values less than the whole number expression. And that's the same pattern in the next week. Whole number expression, 1 place value less, 1 place value less, 3 place values less, 4 place values less. So it will be really interesting to see if the next 5 days follow the same pattern. Something to be thinking about while you're figuring these out for week 3. Sophie says that the first 4 days of each pattern have a white background. And then on the 5th day, there's a color. And I took it a little bit further and said the color matches each rectangle of the first 4 days. So, white background, white background, white background, white background, pink. The rectangles are pink during those 4 days. White background, white background, white background, white background, yellow. The rectangles are yellow during the first 4 days. So with that in mind, it's going to be interesting for you to see, does it follow the same pattern? And if it does, can you guess what the card color will be on the 15th day? Okay, Addie said that you can always use your estimate to help you figure out what the actual area is. And that becomes especially important while we're dealing with decimals. So take a look at that and see on your chart if in fact you can use your estimate, and how do you use it? How does that estimate help you when you're dealing with multiplying with decimal place values? And she also said the pattern she noticed was that the first rectangle is horizontal, then it's vertical, then it's horizontal, then vertical. So what she's saying is horizontal, vertical, horizontal, vertical, and then it's not a model. Horizontal, vertical, horizontal, vertical, and then we have the expression again. And I think when she's saying that it's a horizontal rectangle, it means that the longest length is horizontal. The longest length or dimension on this side is vertical. The longest dimension is horizontal. The longest dimension is vertical. So all really, really good things to observe, and I'm so proud of everybody that contributed. I'm sure a lot of you did it at home and didn't send it in, which is fine, but take out your observations and see if they look like the ones we've made here. I have included it. It's something that this chart is something that your parents can download so you can look at it again. Great job, everybody. Okay, let's go from the March calendar pattern to actually filling out our chart. So we have already together looked at day 11, which is our blue rectangle. If I could get this off the wall, it'd be great. And so we had said that the expression that goes along with this, day 11, is 126 times 304. And we had looked at several different estimates and decided that we would use 120 times 300. We chose that because we could easily see the fact 12 times 3, and we knew that was 36, and then we only had to add on the extra place values. So our estimate became 36,000. When we did the actual, and some of you did the area model, and some of you did the standard algorithm, and some of you did partial products, but we came up with 38,304 square units. And when we compared that to our estimate, we saw that it was pretty close, so that it was a good estimate, and our actual answer was actually in the ballpark of our estimate. So now we're going to do day 12 together. And day 12 together is 126 times 30 and 4/10. So, like somebody said, we know that it has all the same digits, and the only difference is this factor is one place value less than this factor. And so what would we do for an estimate then? Well, we would keep our estimate of 120 the same, 120, and then we would look at this and say, oh, that's really close to 30. Very close to 30. And so again, using our facts, we say 12 times 3 equals 36. And then we have 2 extra place values we have to include, and so we stick on those zeros at the end, and our estimate is 3,600. So again, we can look at our estimate here and compare it. It is actually one place value less than this estimate, and we can look at these again and realize that our factors are just one place value less. So knowing that it's just one place value less and we're going to use all the same digits, we can rewrite those digits. And now we have to decide where that decimal point is going to go. One of the ways we discussed was that we could look at our estimate and decide where would we have to put the decimal point so that our actual answer is close to our estimate. So if we stuck the decimal point here, it would be 3 and 8,304 10,000ths. Well, that's nowhere near 3,600. So you can think for a minute about where you would have to put that decimal point so our answer would be close to 3,600. The other thing that we can do is say, well, if this factor is one place value less than this factor, and these two factors are the same, then our actual answer will just be one place value less. And if it was a whole number, our decimal point would be here. So if you move one place value less, our decimal point would go there. Now, we have to say, is 3,830 and 4/10 close to 3,600? And our answer is yes. So all we have to do is add our square units on the end. And then what did we observe? We observed that our factor is one place value less than our original expression that we started out with, our whole number expression, and that our product or our answer is one place value less than the original product. So we can just write one place value less. And again, we always go back to the original. We don't go back to any of these that we're fixing. We go back to the original whole number expression. So somebody said that they thought the pattern was one place value less, one place value less, 3 place values less, 4 place values less. It could be, it doesn't have to be, but this follows our pattern. This follows that same pattern, but we have to check and see if the rest of them during the week will follow that pattern as well. So that's something for you to do when you download the rest of the cards for the rest of the week. You can see how your answers match up and if the patterns continue. Because remember, sometimes our calendar grid changes the patterns that we're looking at. So good luck with that, and we'll be back later on in the week to check and see how you did with those. Again, I want to remind you that I will be sending home I'll be sending along through the email a new Mathological Liar written by Addie McClasowitz, and we will also be talking about volume tomorrow. So make notes about what you remember about volume and maybe some of the vocabulary words that go along with it. Thanks. Have a great day, and I really hope I see a lot of you today on the parade.